Hello everyone. This seminar is about RecurDyn Python script. RecurDyn VNN R5 released at the end of 2021 is equipped with the ability to use Python script. It is not just a few features, but all features that can be performed in the RecurDyn UI can be executed with Python script. Today, let me explain Python script to you in more details. The order of the presentation is as follows. First, I will explain the introduction to the RecurDyn API and a general overview of Python. For the Python beginners, let me explain the installation procedures and environment settings for Python and its development environment PyCharm. You will also learn how to use the Python script based on the various examples. In addition, there will be an introduction to RDFunctions, an intermediate function library that one RecurDyn engineer developed, and how to use it more easily through examples. First, let's start with the introduction to the Python and RecurDyn API. Python is an interpreted language developed by a Dutch programmer Guido van Rossum in 1990, and is one of the most widely used script languages today. Python's great advantage is its easy syntax, and its extensive libraries allow it to perform a wide range of tasks. Open source license is also one of the great advantages. Python can perform a variety of functions as shown here. Before explaining the Python API, the explanation of ProcessNet must be done in advance. ProcessNet is a solution development kit that can control RecurDyn using C# language. In addition, ProcessNet makes it possible to perform all tasks in RecurDyn by programming and compiling necessary tasks in the development environment called VSTA. Therefore, it is now possible to automate all tasks in RecurDyn through programming. The recently developed Python API leverages the capability of ProcessNet, and the Python API can use all the features of ProcessNet. The functions names and parameters used in Python API are the same as those of ProcessNet C#. Therefore, anyone who has knowledge of how to use ProcessNet can use Python for RecurDyn without any difficulty. However, a separate learning process about Python script is required. The important thing is that you can use most of RecurDyn's features with Python. In other words, it is now possible to automate all RecurDyn tasks using only Python. In this session, I will explain how to install and use Python and PyCharm to utilize Python. To use Python, it is required to download and install Python. Go to www.python.org for downloading and find the download link here. When clicking the Downloads menu, you can see the options listed as shown in the image, and press the All Releases option. Then, you can see a list of previously released versions of Python, and the recommended version here is version 3.8. From the list, Python 3.10 is the latest updated version when I record this video. If you click Python 3.8.10, a list of files appears as follows. Please download the version of Windows installer for 64-bit from the list. Click Windows installer for 64-bit. If the download pop-up window appears, click the Save File button to complete the download. When executing the downloaded file, the Setup window appears. Check the Add Path 3.8 to Path option and click Install Now. When the installation is complete, click the Close button. The last important thing is to remember the installation path of Python. Python is installed in this path. users, account, app data, local, programs, then Python. If the installed version is Python 3.8.10, it will be installed in the folder called Python 3.8. This is the installation process of PyCharm, Python's integrated development environment. Depending on your preference, you may use a program other than PyCharm as an IDE. For example, Visual Studio Code. For now, I will focus on PyCharm. To download PyCharm, search for PyCharm on Google, then click on the first link that appears to move onto the download site. After that, there are two versions on the page, and the version you will use is Community. If you are already using another IDE, skip the PyCharm installation process. Community Edition is an open source based program. Therefore, PyCharm can be used to develop Python applications in commercial companies without any problem. Click the download button. When executing the downloaded PyCharm community installer, keep clicking the next buttons without any additional settings to complete the installation. After installation is complete, execute PyCharm Community Edition from the Start menu. In the first execution, review the Python user agreement and the data sharing option. This procedure is required once only in the beginning. When you run it for the first time, a menu to create a new project appears. After selecting the project folder for Python code development and check previously configured interpreter in the Python interpreter settings, then click button. In the new project window that appears after this, you can see various Python interpreter settings. Select System Interpreter, confirm the displayed path, and click the OK button. Path means the path where Python exe is installed. Finally, when clicking the Create button, the project is created and PyCharm is launched. In order to develop various kinds of applications, it is often required to add the necessary working folders to the PyCharm project. The procedure is as follows. First, click the File button, and then click the Open button. After that, a navigation window will appear. Then, select the desired folder and click the OK button. Then, the Open Project window appears. When clicking the Attach button, the selected folder is registered in the Open Project. It is more convenient to register and use multiple folders than to create and use multiple projects separately. Now that the installation is complete, several settings need to be done. This is related to PyCharm's autocomplete feature. There is a folder called bin under PyCharm's installation folder. And in this folder, you can find a file called idea.properties. When opening this file with the text editor, idea.max.intelligence.file size was already set to 2500. Change this value 10 times larger. Also, increase the idea.max.content.load file size value by about 10 times and then save it. After saving it, run PyCharm again. The next thing to set is IntelliSense's pop-up speed. Click Settings on the File menu to open the Settings window. In the Settings window, go to the Code Completion under Editor and General. You see that the default value of Show the Documentation pop-up in is 1000 milliseconds. The default value of Show the Parameter Info pop-up under the Parameter Info is also 1000 milliseconds. Change both values of 1000 milliseconds to 10 milliseconds. You are now all set to use Python and PyCharm. Next, it is time to learn how to use RecurDyn with Python. First, let me talk about how to run Python code in PyCharm. To run the code, click the execution button as shown in the figure after writing the code. However, at this moment, the code being executed is not the active code that is being edited. In other words, the execute button executes the registered code. If we want the code being edited currently to be executed, it is required to register code in advance. The registration procedure is simple. After activating the code, press Ctrl-Shift-F10 together. This function can be used for the case when the code being edited and the code being executed are not the same. There are several ways to run Python. There are 4 ways to run Python code, including using RecurDyn. The first is to run it using Python IDE. There is a Run button in the IDE and press it. The second is to run it in RecurDyn. A Python Run menu has been added to RecurDyn's Customization tab. You can use it to run a Python file in RecurDyn. The third is to run it using Windows Explorer. Double-click the Python file in the Windows Explorer to run it. The fourth is to run it in the command prompt window. Enter the Python file and press the Enter key to run it directly. Through the methods I mentioned, a Python script file can be used as an execution file. To use Python script utilizing RecurDyn Python API, it is required to install a few Python modules. You can use the general Python module installation method. The installation method can be done by using the module installation command in the command window individually or installing all at once by creating a Python script. The modules required to install for the usage of Python are as follows. First, PyWin32 is an absolute must install. The rest modules such as NumPy, SciPy, and Matplotlib need to be installed for numerical analysis, matrix operations, and visualization. To use the RecurDyn API, the path where RecurDyn library exists must be registered in Python, which is quite simple. Create a PTH file in the folder where Python exe is executed and register the path of the folder you want to reference in that folder. The RecurDyn library path follows RecurDyn v9r5, bin, python, lib, RecurDyn. The installation path of Python exe follows user ID, appdata, local, programs, Python. First, copy and paste the path of the RecurDyn library folder to the RecurDyn PTH file in the Python installation path and save it. Then, whole process is complete. Or, instead of creating a PTH file, you can add the RecurDyn Python library path to the system environment variable. Choose whatever comfortable method for you to use. You are now ready to use RecurDyn with Python. The relation between Python API, ProcessNet, and RecurDyn is as follows. In RecurDyn, an RDYM file and its database have a vertical connection with various elements such as model document, model, body, and joint. The relation can be manipulated with the ProcessNet. This is an example of a Python code. This code is about the process of assigning body classes and creating a joint in the RecurDyn database using Python. Assigning a body from the model means getting only the reference address of the body, not the entire memory data of the body. The creation, modification, and deletion can be performed through various ProcessNet functions. This shows the data type of each object. The first letter starts with I, such as I application, I model document, I subsystem, I body, and I joint. Declaring these data type is essential to use auto-completion such as an IntelliSense in PyCharm. When using the RecurDyn Python API, it is important to refer to the help documents of RecurDyn ProcessNet to gain information on functions and syntax. Here's how to view the documentation. Click the RecurDyn icon here, and then click ProcessNet Help under Help menu. Then the Help window will appear. Click the Search button tab and enter the data type name along with the DF examples. Then the examples of the corresponding Python script are listed up. If you double-click the desired example, the example code appears. Users can create their own Python code by referring to these example codes. Or you can go to the Contents tab and find the example code by yourself. Let's just look through the examples of using Python script. Before we move on, you can access this link and you can download RDFunctions modules and examples I will explain later. The code you see here is for executing and exiting RecurDyn. First, this code imports the required modules, and this is necessary to use the RecurDyn library. Then, get the path where the py file is running. Complete the full path of the RDYM file to be opened. The dispatch RecurDyn function executes RecurDyn. Afterward, specify model document and model as iModelDocument and iSubsystem class. Save the model and close the RDYM file. Finally, exit the application. You can view RecurDyn is launched and closed. First, double-click the startup and close one Py file. Launch it, closed. Execute the second file as well. You can see that RecurDyn is launched and then closed again. The next example is about a code that creates a model and generates and deletes RecurDyn entities such as a body and joint. First, run RecurDyn and create a new RDYM file called model1. Then create body1. Creation can be performed by a function of model class, and the function name is createBodyLink. For the link body, two coordinates are required. Then create a reference frame called refFrame. This reference frame is a class that defines position and orientation. If you open the property dialog box of a marker and a body, you can see the origin and orientation. The class which manages that information is the reference frame. After that, a joint is created through the createJointRevolute function. The final line is for deleting the body. You can see that this code creates and deletes the model, a body, and a joint. Launch RecurDyn, and then create a body and a joint. Move and delete them. The following example shows how to perform the post-process after simulation. You can see that the 4-bar RDYM file is opened once when RecurDyn is executed. To perform a simulation, simulation time and the timestamp are set. Then specify the output folder where the simulation results are generated and perform the simulation. Save the simulation results as an API file. Finally, start the post process via the create plot document function. You can see the post processor is activated after simulation in this example. RecurDyn is launched. After simulation, you can see the animation. And the post processor is activated. You can use plot. This is an example of drawing a curve in plot. After executing RecurDyn as in the previous example, open the 4-bar RDFunctions file. After simulation, start the post process. After that, draw a curve using drawPlot and set the label and title. Finally, save this plot as a positionx.jpg file. You can see the procedure to draw a curve and create a JPG file in this example. After launching RecurDyn, open the 4-bar RDFunctions file. Once performing the simulation, start the post process. Draw a curve and save it as a JPG file. You can see that an image file is created here. Now, let me show you how to use RecurDyn's Python functions more easily. It is to use the RecurFunctions module, RDFunctions. RDFunctions provides RecurFunctions of RecurDyn API functions. Although RDFunctions is not an official module of RecurDyn, RDFunctions makes it easier to use the RecurDyn API. You can download this RDFunctions module from this link. The disadvantages of RecurDyn Python script is that the code length can be long, and the feature of the basic function has no defense code. It means it doesn't have the code to prevent exceptions. For example, if there is a body under the same name when creating a body again, an error occurs during creation because they have the same name, and the entire code process stops, and it is a bit difficult to use without IntelliSense. The code you see here demonstrates these advantages quite well. When executing RecurDyn and opening a model file, the code length becomes this long, even if it's a very simple function, if defense codes for various cases including exceptions are implemented. RDFunctions makes it easier to use RecurDyn Python API. How to use RDFunctions is as follows. Here are some examples functions. RecurDyn can be launched using just one function called RecurDyn modeling, and you can create an ellipsoid body with this just one function, create body ellipsoid. These functions are defined in RDFunctions, and it includes defense codes I mentioned in the previous page. So, for example, there is duplicated body names, there is no error or no interrupt even if you try to use the same name, because these RDFunctions include the defense code. You can download the RDFunctions module from this link. Since it is source code itself, users can modify and use it. To use RDFunctions, it should be located in the same path as the Python script file you want to run, or to have this file in the Python reference path. After that, you can use it after importing RDFunctions module like this. Here is an example using RDFunctions. Many basic functions can be easily used, such as RDFunctions file open with this RecurDyn modeling, or model settings, and create body box, or create joint fix, create joint screw, create for screw, and use expression create parametric value. You can find various examples of code usage from simulation to plot output using RDFunctions. This shows how the test code using RDFunctions work. It executes RecurDyn and deletes all existing entities. After that, create bodies, joins, and forces again, enter and exit the body edit mode. After that, run simulation 3 times. Save the animation. And finally, drawing result graphs. All this process can be done using RDFunctions. RDFunctions enables the code development easier and simpler. Now, I will explain the code with related examples. The first example is a Jansen link mechanism model. The Jansen link is a kinematic drive implemented as a working mechanism using a combination of 4-bar linkage like this. This mechanism was first introduced by the Dutch artist Joseph Jansen, and it is called the Jansen link since then. The joint connection information of the Jansen link is complex. Click the link here to see the corresponding calculation formula. In this example, Python script makes it easier to calculate the positions of complex links and create RecurDyn model with them. What you see here is the calculation formula for each connection point of the links. The given value is the link length. The connection points of the joints can be defined after complex calculations here. You can easily perform RecurDyn modeling using the coordinates of these points. And then it is possible to change the model to create a new one quickly and simply using Python script without the complex calculation. From now on, I will show you the code to create a Jansen link. This is a function to calculate the intersection of two circles. And set the length of each link and apply the scale factor to them. This scale factor is multiplied here. This is the code that calculates the position of each point. Draw the points at each position using matplotlib so that you can see calculated positions visually. Now, let me create a RecurDyn model. Create 7 link bodies using the createBodyLink function. The createBodyLink function deletes the body under the same name when it exists and creates a new one. For your information, unlike createBodyLink, use bodyLink function as a geometry to the existing body without creating a new body. After that, sequentially create revolute joints. Finally, after simulation, play an animation. Let me show you how the Jansen link modeling code works. After executing the calculation code, the topology is shown here. After that, RecurDyn is executed. After creating links and joins, perform a simulation. Finally, play an animation of the Jansen link. The next example is about 4-bar linkage dynamic modeling and design study. Knowing the length of the 4-bar linkage and the information of the nodes, you can calculate its kinematic mechanism. However, it is also possible to obtain more complex characteristics through the simulation in RecurDyn. Let's try this process using Python script. First, parameterize the positions of a 4-bar linkage. Repeat the simulation while changing the position of parameters or nodes. Finally, if you draw and overlap the simulation results, it is possible to more visibly understand what kind of characteristics changes when the link structure is modified. This is the modeling process of a 4-bar linkage. First, import RDFunctions and then delete existing model information. After that, set the gravity information and create the 4-bar linkage nodes information as an array. Then, create parametric points based on the coordinates information above. Now, create link bodies. All control points are defined as parametric points. The lengthy code is due to the parametric modeling using PP, parametric points. Starting with the creation of link 1, link 2 and link 3 are created in a similar way. Create joints using the links and parametric points previously created. First, create joints and use the joint markers as parametric points reference frame. Use this copy-based-to-action function to copy the reference point. Create from joint 1 to joint 4 in a similar way. Finally, once the simulation is done, play the animation. So far, we have reviewed the code that performs the parametric modeling of a 4-bar linkage. You can see that the process is not that simple. Therefore, it is recommended to parameterize the model using parametric values or parametric points in RecurDyn UI first, without using script. After that, use Python script for changing parameters, simulation, and reviewing the results. This is the code to perform the parametric study of the 4-bar linkage model. First, import the related modules. After that, execute RecurDyn and open 4-bar RDYM file. Get pp0 to the variable pp, and change the coordinates of pp using the for statement, and repeat the simulation process. In this process, extract the results of expression predefined in the model such as exmeax, exmeay. Finally, draw a plot using matplotlib, the Python plot module. Let me show you the process of modeling a 4-bar linkage using Python script. Parameter points are created here and links joints are created. Then simulation is performed. After that, you can see the animation. And this is the process of performing a design study using the 4-bar linkage and reviewing the results. Run RecurDyn and open the 4-bar linkage model previously created. Perform the repeated simulation by sequentially changing the position of PP. Finally, moving path of the endpoints of each simulation is displayed using matplotlib. The next example to show you is frequency comparison according to the initial angle of a simple pendulum model. If recalling what you learned at school about the period of a simple pendulum, you may remember the square of the period is proportional to the length of the pendulum. The complicated latter term was ignored at the time. In fact, the period is affected by the initial angle. Since we use multi-body dynamics, we can use the full formula. I created a code to check if the result calculated by RecurDyn is the same as the theoretical result of the complex formula. Like the previous 4-bar linkage model, the simple pendulum is created, and the initial angle is changed, then simulation result is compared with the theoretical result using Python script. Let me show you the code. As before, import RDFunctions module. Run RecurDyn, and then open the Pendulum RDYN file. After deleting all existing bodies, set the gravity. Create bodies and set mass and moment of inertia. Also modify the position of center marker CM. Once creating a revolute joint, you are finally done modeling. To conduct the design study, create an initial angle array. Set the simulation time and number of steps, and set the joint's initial condition. Next, perform a repetitive simulation using the for statement. To review the simulation results, launch RecurDyn plot and import the simulation results. After getting FFT results, extract the frequency characteristics. In this case, the FFT of RecurDyn plot has been used. Of course, RecurDyn plot is not the only way for this process. Rather, in other cases, it may be convenient to use the numerical analysis functions of Python. Here is the code to calculate the theoretical frequency of a simple pendulum. The frequency calculation includes an infinitely loop of factorial calculation, but it can be calculated in a finite way. Finally, compare the frequency calculated by the simulation with the theoretical frequency. Here is the comparison process between the simulation results and the theoretical frequencies of the single pendulum. Run RecurDyn, create a pendulum model, and then perform design study. After finishing multiple simulations, perform FFT using post-processor to compare the results. You can see that the frequency changes according to the initial angle. This is the initial angle and this is the frequency. Also, the graph shows that the simulation results well matched with the theoretical results. This line is the theoretical results and this dot means the simulation results. The last example shows the process of obtaining the natural modes and frequencies according to the drum rotation speed of the washing machine. In a system that rotates at high speed, inertial force is generated according to the rotational speed of a body. This force is commonly called Coriolis force. For this reason, the natural modes and frequencies of the rotating body can change depending on the rotational speed. A typical example that shows these characteristics is a washing machine. It is recommended to use RecurDyn's eigenvalue analysis feature to observe the changes in the eigenmode of the washing machine. The whole process is as follows. Prepare a parameterized washing machine model and input the initial rotation speed. After that, perform eigenanalysis in the steady state. Then, change the rotation speed again and perform eigenanalysis again. By repeating this process, you can obtain natural modes and frequencies according to the various speeds. This is the Python script for this process. First, execute RecurDyn and open time-loading washing machine RDYN. Assign PV from RecurDyn parametric value PV RPM. Perform the eigenvalue analysis while changing the RPM using the for statement. In this process, there is a possible feature due to using Python. That feature is to extract the natural vibration mode from our file in the form of a table. Python's powerful string handling functions make it easier. In other words, when using Python, it is not difficult to extract tables or numerical values from text files. This functionality is surely implemented in RDFunctions. That's text file read eigenvalues. Mode shape animation is also extracted for each mode, and these animations can be merged as one video file using the MoviePy module of Python. You can see the all mode shape animations with this one video file. Lastly, the frequency information generated by using Python is saved as a dump file using the pickle module. It is used for debugging. Create a new Python script file and open the previously saved information using pickle module. Draw the extracted natural vibration mode frequency as a plot using Python's matplotlib. Let me show you the process of the eigenmode analysis and its result comparison. Run RecurDyn and open the washing machine model. After that, obtain the natural vibration mode for each rotational speed of the drum. You can see that the eigenvalue analysis is performed repeatedly and the AVA file are saved. Once completing the analysis, save the mode shape animations for each mode as a separate AVA file. After that, change the speed of the drum and perform the eigenvalue analysis again and again. Once completing the eigenmode analysis and saving process, save the information as a dump file. After the second process, it is possible to view the changes of frequency according to RPM. Open the AVA file to check the animation of the mode shapes. This file contains all mode shapes of each RPM in one file. And as you can see, the natural frequency changes as the rotational speed increases. If you observe the change in natural frequencies, you can see the tendency of the natural frequencies to increase due to the rotational inertial resistance as shown in the plot. However, these changes mainly occur near the rotational frequency region, and the high frequency modes are hardly affected by the rotational speed. Now, here is the conclusion. Being able to use Python script with RecurDyn means that the usability can be improved dramatically. By using RDFunctions module introduced in this seminar, you can more easily use various RecurDyn functions with Python. Most tasks in RecurDyn can be done using Python, and code development and debugging are easy and convenient because Python is an interpreted language. One of the most important features is that you can also perform various post-processing tasks using Python's rich libraries. Also, you can easily access many examples and tutorials of Python via Googling or YouTube. In the case of dynamic simulation, the individual analysis time is relatively short. However, it is often necessary to identify tendencies through repetitive simulations, so the total analysis time can be long. In this case, the efficiency of these repetitive tasks can be greatly improved by using Python script. I hope all users will fully benefit from these features while working on RecurDyn. Until now, we have learned much about how to use RecurDyn Python script. If you have any questions about the seminar, please visit Function by Technical Support site and contact us for more details. And again, you can download the RDFunctions module or examples introduced in this seminar from this link. Thank you for sharing your time and see you next time.